Hello, friends. Today we are going to start the new topic, that is basic principles of organic chemistry. In the introduction lecture, I have already told you chemistry is divided into mainly three parts. First is physical chemistry, second is inorganic chemistry, and third is organic chemistry. In physical chemistry, all physical quantities are studied, whereas in inorganic chemistry, all the element except carbon is studied. But in organic chemistry, only compounds related with carbon is studied. So organic chemistry is the study of carbon compounds. So carbon compound, it is more than 5 million organic compounds are already discovered, starting with methane containing one carbon to DNA and RNA containing millions of carbon atoms. So organic compounds contains one carbon atom to 100,000 and millions of carbon atom compounds. I have already told the use of organic chemistry in our daily life. In food, we eat carbohydrate, proteins, fats, all are organic compound. In clothes, we wear clothes containing hydrocarbons or cotton, jute, silk, all are organic compounds. In medicine, many antibiotics, many pharmaceutical products are organic compounds. We use paint for our household purpose. We use dyes to color our hair or clothes. All paints and dyes are organic compound. We use fuel for our two-wheeler, four-wheeler or any motor. All fuel like LPG, like petrol, diesel, rocket, kerosene, CNG, all are organic compound. In agriculture, many phosphates, sulfates, or many agriculture products are organic compounds. The cosmetic, that is all the paste, creams are organic compounds. So there is a very vast use of organic compound in our daily life. Now we are going to study our topic with structural representation of organic molecules. Many organic molecules are represented mainly by first two formula. First is dash formula. I have shown the structure of methane containing one carbon and four hydrogen, and there is a single line. This single line indicates the covalent bond between carbon and hydrogen. So one carbon forms four hydrogen bond in methane, whereas four covalent bond with hydrogen, whereas the second example is ethane containing C2H6 formula, in which one carbon forms covalent bond with three hydrogen, another carbon also forms covalent bond with three different hydrogen atoms, and two carbon themselves forms covalent bond. So this type of representation is called dash formula. The same formula is represented by using electron dot formula also. You can see here, instead of this dash, instead of using line, two dots are used. These two dots indicates the electrons. Suppose every carbon and hydrogen, there are two dots. These two dots indicates the sharing of electron. One electron of carbon is shared with hydrogen, and one electron of hydrogen is shared with carbon. So each carbon shares four electron with four hydrogen, and every hydrogen share one electron with carbon. So it is represented by dot formula. The point to remember that two dot indicates one covalent bond. So in the ethane, you can see there are two dots between carbon atom, two carbon atom, and again two dots between every carbon and hydrogen atom. So this type of covalent bond, two dot indicates one covalent bond. And definition of covalent bond is the bond formed due to sharing of electron is called covalent bond. So this is the important property of organic compound. Every organic compound, the bond formed is covalent bond. Due to covalent bond, many compounds are formed in organic chemistry. Now third type of representation is condensed formula. It is again simplified formula of dash and dot formula. CH4 condensed formula is written as only CH4. Ethane, the condensed formula of ethane is CH3CH3. Similarly, the condensed formula of propane is CH3CH2CH3. Or the condensed formula of ethyl alcohol is CH3CH2OH. There is no straight line, no bond line, no dot directly up. Its chemical formula is mentioned. This type of representation is called condensed formula representation. Now the fourth and a new type of representation is bond line or zigzag formula, in which no carbon hydrogen is written, only a zigzag line is drawn. For example, propane is represented by only the curve as shown in this figure. This curve indicates that there is one carbon at the start, one carbon is at the middle, and one carbon is at the end. So there are three carbon atoms, and the first carbon carries three hydrogen, therefore there is a CH3 group. Second carbon contains two hydrogen atoms, it is CH2 group, and again third carbon contains three hydrogen. Similarly, butane is represented by this formula. So you can see at the beginning of this structure there is a CH3 group. In the middle portion, upper side, there is a CH2 group. In the lower side, there is again CH2 group, and at the end there is CH3 group. Or ethyl alcohol. Ethyl alcohol has a formula CH3CH2OH. At the beginning there is CH3 group. In the middle side there is a CH2 group, and OH is attached to CH2 group. So this type of representation is called zigzag formula, or it is also called bond line formula. Here is your homework. So first structure is butane. Condensed formula is written in two types, CH3 CH2 twice CH3, or again it is written as CH3 CH2 CH2 CH3, and its bond line or zigzag formula is also mentioned. Now we have to complete the remaining part of this table. Here the bond line or zigzag formula is given. You have to write its structure, dash formula, then condensed formula A, then condensed formula B. And if you have any doubt, you can ask me on WhatsApp or call me anytime. Or if you tried this, draw this table on paper in book and take a picture and send it to me. If there are any correction, I can call you and I will correct your mistakes. Now next type of formula is wedge formula. Now this sixth type of representation is a three-dimensional representation. For example, in methane, wedge formula of methane is given as here is clear structure. Wedge formula of methane, there are two straight line bond. One is a solid bond and one is dotted bond. So in three-dimensional, if you consider carbon is on the paper, take one paper and draw carbon on the paper. Then two hydrogen atoms are again on the same paper, but one hydrogen is above the paper, which is shown by a solid bold bond, and one bond is below this paper. It is shown by a dotted line. So this type of structure is a three-dimensional arrangement. It is called wedge formula of methane. Now this same type of formula is written by Fischer projection formula. In Fischer projection formula, you can see here there is a cross sign. So this Fischer projection formula is also called cross formula, in which methane is represented by simply drawing cross and hydrogen at each corner. We have to understand that there is a carbon atom at this cross point at the center, or ethane. On the top it is written by CH3. In the center there is a carbon, and this carbon is again attached to 3 hydrogen atoms. Or ethyl alcohol, third example is ethyl alcohol, in which CH3 group, in the center there is a carbon which is attached to 2 hydrogen atoms, and again it is attached to OH group. This type of formula is called Fischer's projection formula. You can see here, this is again example given in your textbook. This Fischer projection formula is also shown by wedge formula. In the wedge formula there are 2 solid lines, that means 2 bonds are above the plane, above the paper, and 2 dotted formula, it shows they are below the plane. Or same type of Fischer formula, it is represented by wedge formula also. The straight single line indicates the bond is on the plane or on the paper. There are 4 bold solid bonds, indicates 2 hydrogen and 2 OH atoms are above the plane, and there is a dotted line with COH and CH3, that means both COH and CH3 are below the plane. So this type of representation is called Fischer projection formula. So today we have seen 6 types of representation. First is dash formula, represented by a single straight line. Then second we have seen dot formula represented by 2 dots. 2 dot indicates 1 covalent bond. Then we have seen a zigzag like structure in which there is no carbon, there is no hydrogen. We have to understand where is carbon. So at every point from the beginning to end, at every cross point there is a 1 carbon atom. Then we have seen wedge formula, which is a 3-dimensional view of a molecule. And then we have seen a Fischer projection formula, in which the structure, if this structure is placed in front of you vertically, how this structure looks at you. This type of representation is called Fischer projection formula. In the next lecture we are going to start a very important discussion on how organic compounds are classified, and it is going to be very important for 12th your HSC examination. So today we will stop here. In the next lecture we will see the classification of organic compound based on structure. Thank you.